Hey, what's up guys, my name is Cherno and welcome to episode 115 of Game Programming. So last time we took a look at the UI manager. We made a UI manager and we made this basic user interface here where, as you can see, we are drawing things onto, like, I guess, a separate panel or a separate layer from the actual game. Now, I've thought about this a little bit and how we want to do this, and I've realized that there is one kind of fundamental problem with making a user interface with our current setup. And the basic reason for that is, remember, we're drawing all of this game stuff, we're rendering all of our game stuff at a scale of 3. What that means is that one pixel on our screen, which is 1 by 1, suddenly becomes 3 by 3 pixels. So that means that, and that's great because we're going for like kind of a low fidelity, old school kind of look, and it works really well. It's a really nice aesthetic and it's brilliant for our game and any text that might appear in our game as part of like the game panel, game viewport thing. However, our user interface, we probably want that to look quite sharp. So we don't want that to look low resolution. Well, at least, you know, you might. This is just my opinion. And I happen to be the one making this game, so yeah. But what I wanted to say was that even if we tried to go into, I don't even know where this is happening. I think it's in UI label. It's been a while since I made the last episode, but for those of you who are wondering and hoping that I will be making more episodes quickly, that is going to happen because I'm kind of, I guess, taking a break from Sparky, and I'm going to try and put out at least 10 to 20 game programming episodes before I take another break from this series. So that's the idea, so don't worry about that. You'll get a ton of episodes coming your way. But what I wanted to say is, even if we go ahead and, so this is our rendering, so one of this will be the size, right? Oh no, that's right, we don't even have a size, that's locked to the bitmap. So all of that stuff, right? We've got this kind of problem where we kind of want our user interface to be high fidelity and high resolution, but we want our game to look low resolution. And if we take a look at Realm of the Mad God, then you can see that, I mean, Realm of the Mad God is generally a pretty high resolution game. We're not sticking to their aesthetic exactly. I mean, they're high resolution in this. I don't like to call them a high resolution game because they don't really look like that. You can see these trees have huge pixels, as does the ground and all of these things. It looks low fidelity. Their entire rendering engine, though, it looks like is actually just rendering high resolution graphics, right? And I don't want to dig too deep into the technicalities behind this, but I mean, Realm of the Mad God, I believe, is made with Flash, and that is certainly very good at rendering things like this. But the idea is that that would be at native resolution, that would be at full resolution. It would not be like this kind of scale factor where we'd render things seemingly very small and then stretch it out. That clearly isn't happening here. And you can see it from the subtle, like, shadowing. I don't really want to call it shadowing, but you can see the kind of, I don't know, fake ambient occlusion, if you will, around pretty much every tree and every object like that, which basically tells me straight away it's pretty high resolution, and also this really thin black outline. But the idea is they've gone for low resolution textures on a high resolution rendering kind of setup. That's not what we're doing, right? We're going for a low resolution rendering engine straight up. Because we're doing that, that does complicate things. But the other idea is, yeah, their interface looks pretty good, and we want our interface to look pretty small. We want characters, you know, that small, where it says our attack stats and whatnot. We want to be able to do all that, but we can't do that with our current setup because our viewport and our rendering engine is actually limited to being at a low resolution. So, what can we do? Well, luckily, there are a million ways to fix this. One of the most obvious ones might be to just make another rendering engine, which I guess runs at a high resolution. And by that, I don't mean like literally, let's make another rendering engine from scratch. I just mean set up the current engine so that we can make another viewport instance, which is high resolution. But what I want to do instead is basically the same thing, except we're actually going to use Java's 2D graphics. So what we've been doing up until now, and there's a reason for that, there's a big reason for that, is we've been basically not using Java's rendering API. All we're using out of Java's rendering API is literally draw image, okay? And that's it. And the reason what we do with that is we draw our pixels, which is what this whole rendering engine is about, right? All this rendering engine is about is basically composing an array of pixels and then just drawing them onto the screen as if they were any other image, okay? That's all we're doing. And because we decide the color of each and every pixel manually ourselves, right, we have full control over what this game looks like. We can do anything we want, okay? Because that's the case, and I mean, yeah, like, we can totally do anything. Like, if I was to just say -50 or something, and this is going to be crazy, but you can see I can change everything straight away, okay? And that's not even something that, it's, you know, it's not even, look at that, like, it's crazy. You can do anything. And the reason that's really good, that might actually be a more subtle effect, because I am subtracting 50 from black, which is going to give us a negative number, which is why it appeared all white. But anyway, the point is we can do anything with these pixels, and that's great because that's what I want to be able to do, okay? I want this game to look exactly what I want it to look like, whereas if we use Java's stuff, we can't do that. However, for the user interface, I think it's fine because all we're really going to be rendering there is text, okay? Now, I know you might be concerned about the mini-map in the top right that we probably want to implement eventually. Remember, that can actually just be an instance of our rendering engine if we really want it to be, okay? I'm talking about for like text rendering and whatnot, okay? So that's what we're going to do today. We're going to basically create another kind of rendering engine that deals with Java's graphics. That will be able to render high resolution stuff. And in fact, if you're concerned about what this will look like, whatever, it's actually, you can actually just try it out really easily. After we draw our image, oh, and this is another thing I should mention, this isn't going to work for, you really shouldn't use this in the game's viewport. Think of this as like a high resolution overlay. That's exactly what it is. It's a UI overlay kind of layer, okay? So if I just go ahead and go g.drawString, I can call it, say, hello, same as the other one, and I can position it somewhere like 50-50. You can see it right over there. It's actually kind of small, so let me just fix that up by setting the font to, I don't know, Arial. Arial's a Windows-only font, so probably not a great idea, but whatever. And we'll set it to like font size 50 here. Oh, I'm getting hacked. What is up with you? String int. Is that not what I've done? What? Oh, yeah. Sorry. That's what I meant. Not our font. There you go. You can see it's bigger. And if I set the color to white or something, ugh, I can't spell today. Won't. Oh, come on. Alright, if I set the color to white and import it, oh, it just gave up on me. You can see we have hello, and you can see that's perfectly high resolution. Okay, and we can set that to however small we want it to be, and is generally pretty good, you can see. Okay, now what we could do if we really wanted to, and you guys might be thinking, all of you guys who are probably a bit experienced and whatnot might be thinking, why don't you use Java to generate a font, basically to generate all your font glyphs and rasterize them, and then simply take them into a pixel array and overlay them and basically integrate them into the engine as just a bunch of pixels like any other sprite. You could do that, but unfortunately that is not going to work in our case because it will still be scaled up by 3. Okay, it will still be scaled up by 3 because that's how our engine works. As far as our entire rendering engine is concerned, we are dealing with a resolution of 300 by 168. That's it. That's all it can do, okay? In the very last step, once we've already rasterized everything and rendered it, it then gets drawn at a different resolution. Because if I did draw it at width times height, you would see that it would look like this, and it actually probably won't remove the background there, so this will look very, very weird. But that's what it will look like. Let me... Is that the right... No, it's clearly not. It's just width height. There we go. So if I did this, you can see this is what our game actually looks like in this corner here. And I apologize for the... let's just quickly fill in a rectangle. with that so that you can actually see what it would look like. So that's what it would look like. This is what our game actually looks like when it gets rendered. And then what we're doing is we're saying, let's literally stretch it up a bit. But what I mean is the rendering engine is concerned with this resolution, which means that we can't actually do what I described earlier, which is just taking the pixels from Java's kind of text generation, or even using something like FreeType to generate our own glyphs and rasterize them. Not going to work in this case, and really it's a lot of work, and the performance won't be great either because it's just an extra step that we're doing for no apparent reason. But that's the idea. So if I get rid of this and go back to drawing this image at basically width times scale, or I'm just doing get width, get height, which gets the height and width of our window, so it fills the window, whatever resolution that might be. You can see we get this going on here. Fantastic. So there we go. But the point is we want to be able to do stuff like this. Okay? So that's what we're going to do. This is kind of an explanation episode and whatnot, so I hope you guys enjoyed it. I'm not going to end it here, obviously. We've just started, as I'm being on for like 11 minutes, but I'm going to explain the general setup of this engine, and we'll do something like that. So that is the plan. Let's stop drawing all this stuff. We'll go back to what we had before, which was this. Okay, so how's this going to work? Well, that's a good question, because I don't actually know. I haven't looked at this code in a fair while. So let's take a look at what our screen looks like. And this is going to be good, great, like a great refresher for you guys as well, if you haven't looked at this in a while. So the way we draw stuff right now is pretty basic. We've got a screen class, and yeah, and we just draw things. What we want to be able to do, right, is for our entire UI setup right now, we're still rendering it with a screen. Okay, what we want to do is something slightly differently. Oh, rather slightly different. Okay, we want to instead of taking screen, we want to basically take in Java's graphics object. The other thing we want to be able to do is in our game here, we want to be able to instead of having to do this before this pixel stuff, which as you can see we do here, UI manager.render, we want to do this afterwards over here. The reason, yeah, so that, well, the reason we want to do that obviously is because we want to do it as an overlay on top of our rendering engine. Okay. Now it shouldn't matter because we're actually going to change this slightly so that it doesn't fill in the whole area, okay? So right now, you can see we are rendering hello, but that doesn't actually matter. This game is actually still rendering all across here. It's then getting overwritten by a bunch of, I guess, I don't know, extra pixels to make up this gray background and whatnot. So we will reduce our rendering area, so that's not the case. So in that case, it wouldn't even matter what order you render it in. It's just that we will be rendering it at a separate rate to this. So what we want to be able to do is basically call UI manager.render with probably Java's graphics object. The other thing is, once we dispose the graphics object, we do need to recreate it, which is what happens by bs.getDrawGraphics. And because of that process, it's also a bit complicated to just be like, let's set a graphics object in a screen, say up here, and then we don't have to refresh it. We actually do, which is why it's perfect if it goes into here. Now, the other main problem is that we actually can't kind of function at the level we're at right now, because when we do stuff in UI Manager or UI component or whatever, all this vector2i stuff, all of this positioning of things, screen to render sprite at a particular position, you know, we've created one at 80, 168, whatever, that, as you can probably tell by reading stuff like 80 and 168, is actually relative to this resolution, of course, because we were using our rendering engine, which only knows about this resolution, yeah? Java graphics is a bit differently. It actually functions based on the size of the window, okay? Because it's per pixel, not per 3 pixels, which is kind of what we're doing. So because of that, we need to make a decision whether or not we want to deal with that anyway, because if we do, we need to divide everything by 3, or rather multiply everything by 3. So again, I'm not sure if you really want to deal with that or whatnot, but you certainly can. I'm trying to desperately think right now while I'm talking whether or not this kind of new rendering engine will actually have anything to do with stuff other than UI Manager, because if it doesn't, then what I've basically written right now is actually really good. However, if it does, I'll get rid of that. If it does, then it will be better to make like a class for it and actually set it up properly. But I think this is fine. I'm just gonna go with it. So So we're switching to graphics G for this. Let's import that. We'll grab G, pop it in here. This is now graphics G. Let's import that. And again, screen.render sprite will be something else. This sprite that we've created is just a like a gray thing, so we can probably ignore that completely and just do something like g.fillRectangle. So this is where it becomes important. Yeah. So this, we did it at 80. Why did we do it at 80? Well, where is, oh, it's because it's relative to something else, isn't it? Okay, this is where it becomes a bit complicated. We'll still do it at position X, position Y. We probably want to be able to make sprite rectangles as well, but this is a UI panel, so we'll have a vector position and a vector size. And we'll make a size. Oh, I see. That was the width and height. Okay. Not the position. So position.x, position.y, size.x, size.y. Now, of course, we need a color as well. But we can get rid of sprite, because sprite, remember, is our engine. Let's keep that color, though. And then we'll make a private color equals new color. All right, so there we go, and that's Java's color. Okay, cool, there we go. So we've got basically the same thing we had going on here, except instead of this, we're kind of doing that. Remember, position.x, position.y doesn't need to be multiplied by 3, which we'll deal with in a minute, and component.render will take in G as well. Okay, there we go. So there's a lot of talking here and a lot of refactoring. But this, of course, will yield much higher resolution graphics for UI stuff. And then over here, we try to create a new panel at this kind of thing. That's fine. Remember, when you do stuff like this, okay, it now needs a size. So I think we went with 80, didn't we? So just multiply 80 by 3 for the size. And then we went with 168 times 3 as well. Hopefully we won't get too many like rounding errors. I don't think we will. Should be fine. And by new UI panel, I meant new vector 2i, clearly. All right, there we go. So this stuff as well needs to be multiplied by 3. Make sure you obviously multiply. Oh, it doesn't matter which way you do it. Just make sure you either multiply both of them by 3 or, well, one of them. Or just do the thing and then multiply by 3. It'll give you the same result. There we go. So we've refactored this. Let's just launch it and see what happens. Okay, we get a nice crash because size is probably null. Yeah, so let's make sure that we make this dot size equal to size. All right, so you can see we've got the exact same result. That looks a bit darker for some reason. Does it? I don't know. It does look a bit dark. Let's, oh no, I know why. It's because we're not actually setting the color. So g.setColor, color. And there we go. So it looks exactly the same as before. We, of course, lose our hello text thing that we had. Where were we even doing that, though? Font.render. So the UI label was doing that. So now, I guess we go UI label, render. Okay, where is this coming from? Where do we have our UI label? Did we add it as a component? I guess we did. Component.render G. Oh, okay, I see. So we were overriding it, but we're not anymore. Whoa, go away. We were overriding it, but we're not anymore because we changed that. So let's go to this situation here. Let's get rid of font. Oh no, we can keep font, just not our font. So java.ort.font. I think we'll have a default font and then we'll just do like set font or something. So I'll use like Helvetica or something. I don't know, something cross-platform. Helvetica, so this is the style we want. So the style, I think we have like a enum for that. Not an enum, but like a bunch of... Yeah, here we go. We got stuff like bold, which is 1, I think. Like it's physically equal to 1. We can check. Yep, 1, and italic is 2, and whatnot, and that's apparently all we got. I think there's bold italic as well, but I don't know what that is. Anyway, so we'll just keep that as 0, which is just no style at all. In fact, I think there was a... So plain. It's better to use these instead of just 0, because it makes more sense when you're reading the code. Because you're like, ah, font to plain, I see. And the size, we'll keep it like 30 or something. I don't know, 32. Okay, so that's what we had before. So let's kind of match this stuff. So first of all, let's set the font to font. We need a color as well. Let's just make it like pink or something. That'll be like the default color if you haven't set one. Just to remind you to actually set a color. I think I'll do it in that order. It doesn't really matter. Okay, and finally g.drawString. So the text is what we're drawing. We want the x and y, so it will be this stuff. It will be exactly this stuff actually. And we don't get stuff like spacing and whatever, unfortunately. But there we go. Okay, so it's up to whatever sets this UI label to actually set the position correctly. So what does set the UI label? Was it in the panel? And the set offset again has to be correct. So if we just run this right now, I imagine we probably won't see anything, or we'll see something up there, which is a bit weird. Because all of the offset stuff is wrong. So in UI panel, or does player do that? Oh, here we go, player does that. So -10, why was that -10? Oh, it's because we had heaps of padding. Okay, so let's just make this at like, remember this is in real pixels, so let's just go 10, 10, 10 or something. Alright, and then now the set offset, whatever does that, needs to function correctly. So UI label, UI component, I'm just trying to find it, UI panel. No, when we make a panel, we've got the position, it's the offset, right? Component.render, yeah, component.set offset position. So that should be actually correct. Oh, I believe it might be because Java draws stuff at starting from the bottom left rather than the top left. That would be weird though. I didn't think that was the case. But if we draw it at the very bottom of the screen, which is 168 times 3, we can probably verify that theory. Yeah, you can see that it draws it from the bottom left. That's the position. A bit weird, but whatever, we can deal with that. We could use like font metrics to actually offset that so that it is the top, but that's an unnecessary performance loss that we just don't need. Okay, cool. So there we go. So now we've got this in high resolution, and it looks exactly the same as it did before. It is pink, but that's okay. Point is, it looks the same. We can't actually position this live, but there you go. So that's the basics of our new engine. Anything we can do here, anything related to Java graphics we can do here, okay? We could even make a custom pixel array if we wanted to do something that wasn't kind of supported by Java. So in other words, if we wanted to draw like some weird mini map or apply some kind of post effect or something, we could actually make a pixel array, render what we want, and then do that. So we can still do that. It's just that this is like a separate, it is literally a separate rendering layer to our actual game, and that's the way it should be, okay? Alright, cool. Any questions, leave them in the comments below. Let me quickly just do one thing, and that is for UI components. We really should have a color for the component. So I'm going to just grab this, pop it into components as protected. We'll make it public. We want to be able to change these things very easily. I will make this a getter, setter actually for this. Just because it will probably look better in code. But yeah, everything else we want to pretty much keep public so that it's easy to access. And since we'll be both getting it and setting it, there is absolutely no point in making a getter and setter, and that would actually reduce performance. So I don't know why some people insist on having getters and setters. It's actually incredibly bad in many cases. Okay, cool. Anyway, that being said, we can Control-Shift-O this to get rid of any other unused imports. This looks pretty good. We didn't, yeah, the color we can set ourselves. So if I'm like, I want this UI label to have a particular color. In fact, I might just make this return. The reason set color might be nice is because you can get it to return stuff. So, for example, I'll show you what I mean. If I go public UI label, set color, and I'll do this to font as well. I'll just take in an int. We can get it to set the color equal to, and I don't know why I did this in here. Let's do this in UI component. We can make color equal new color. Color. And then we can return this. And this will be a UI component. Okay, and if we do stuff like this, then the reason that's so nice is because it means that we can do stuff like, you can do this inline. So before I would have had to do UI label equals that, and then label.setColor, and then label, right? But with this setup, I can just simply say dot set color to, let's just say black, and then you can see that it totally works and I don't have to do anything like that. So that's a good strategy as well. Pro strategy. Okay, anyway, that being said, there's our text. You can see it's rendering in high resolution, so we had the same thing as before. If you guys want to use what we had before, that's fine. That's actually why I showed it to you guys, so that you can actually use it. You can actually keep your interface low res and matching your actual game's rendering engine, like we showed before. But this is the way that we're going to stick with it, because this allows much higher resolution text, which is important since we want the text to be quite small. Anyway, if you guys enjoyed this episode, please hit the like button, and I'll see you guys very, very soon with a new one. Goodbye.